Hello and welcome to the next segment of the Life Science and Technology series. My name is Ray Doyle from WB Engineers and Consultants. I'm a Life Science Practice Leader. This segment will focus on chemistry labs, and chemistry research. So at the beginning of this, I'll give you a little bit of a differentiator between, in the world today, life sciences speaks to biology first. And in the world of biology, that speaks to what a lot of the researchers call large molecules. Large molecules just being the definition of how big the molecule chain can be to actually support therapies or treatments or drugs in the biologics world. In chemistry, the topic of the day we're really focusing on is small molecules. And the idea of being a smaller molecule doesn't mean it's small, it just means it's a lot smaller than a biology molecule. And what's key to that is that you really are dealing with chemicals and chemical chains, and that's really the difference. But once you get past the science that happens, you have to deal with the facility and the building that it all happens in. The idea that in a chemistry lab, you have many types of chemistry labs, from analytical labs to organic labs, non-organic labs, and then there's material science testing labs, there's research and development labs where they're just doing things that nobody's done yet before. They're creating new molecules that may or may not be useful to society, or to, in the case of early drug research, ended up actually being used to help formulate drugs. So the need to have space to perform chemistry is what we really want to talk about. We want to try and figure out what is needed that makes it different than another building type. So the first thing that happens in a lab, you have fume hoods, and they are the containment device that protects the researcher from the science that's happening inside of the hood itself. So you think of something that has a catalyst. You might add heat to something to start a reaction that creates smoke, creates fumes, creates toxic gas sometimes. And the fume hood is there to protect that scientist from exactly what could be in the hood. And those are designed to move the air from the room across the body of the researcher into the sash of the hood and then out of the building. In some cases, they have things like energy recovery on them to recover the energy that's being exhausted out of the building. The other part that you need to know is that as the air gets exhausted, what goes out must come in. You have to have outside air makeup systems. You have to have something called dedicated outside air unit system that makes up that exhaust. That then becomes a large piece of mechanical equipment, and it costs a lot, and it takes up a lot of space and uses a lot of energy. So when you're looking at buildings for chemistry, whether it's new or existing or repositioning, you need to keep all of that in mind. The other side of that is that there is a fair amount of power needed in a chemistry lab building. You're looking at a lot of normal power, can be anywhere from 5 watts to 25 watts a square foot, depending on what kind of research you're doing. But also important there is the idea that you need emergency power. So if the science requires something to be backed up or secured for the long-term benefit, they don't want to have to lose that research or lose that information that was being acquired in a power outage. So you'll see emergency power, standby power generation systems for most chemistry and lab buildings. In this case, you also have to have them for life safety. You need to have the fume hoods on a manifolded system where you have multiple hoods exhausted through a fan that is supported by generator power. So that's one aspect of a chemistry building. The other side is the plumbing side. The plumbing side of a chemistry building brings a lot of different gases. You could have things from natural gas to argon to helium to oxygen. You could have combustible gases, of many types. So you really have to be really careful when you're talking about the life safety of a chemistry building and understand what they're doing in the building and why they're doing it, so that you can protect the occupants, right? The main thing we want to do is provide a building that's safe, but is also useful. So that life safety portion of the systems and the evaluation of each building needs to be performed by a professional that is well versed in that life safety code, the maximum allowable quantities of toxic and flammable chemicals, and how they get stored, how they get exhausted and ventilated, and sometimes how they have to be treated in the event of an actual hazard. So you get into classifications that can be well beyond just standard sprinklers. You could run into situations where you have a hazardous storage room that could require much more than that, such as containment of the sprinkler water because it can't go down the drain because it's so toxic or flammable or explosive that it could be a hazard to the surrounding community. So you can see how it can get dangerous and very, very detailed very quickly. But I want to stay high level, and I want to go back to one of the things that you need to really capture as you look at these project types when we talk about chemistry. Remembering that the idea that chemistry is less used for pharmaceutical work than it used to be is very true. But the fact that there's chemistry labs and chemistry companies that are creating very important materials that better society is very interesting. I think when you start talking about things like battery research and battery chemistry, that is very much an emerging technology, and a lot of research is going on today. The other piece is materials, things like Kevlar, sort of chemistry products. You get things like Tyvek, all of that stuff becomes kind of a chemistry product. Gore-Tex, and a lot of the paints and polymers and things like that are all coming out of these chemistry research labs. So if you have any questions about chemistry, we'll be happy to entertain those via email or in a Q&A. But I want to close this segment with a quick statement to say thanks for joining us again. I look forward to the next one.